Hi friends, welcome to Triple Students YouTube channel. So today we are going to know about the mechanical systems and electrical systems. Okay, so first we are going to know about the mechanical system. Mechanical system. Okay, so there are two types of mechanical systems are there. First one is mechanical translational system and another one is mechanical rotational system. Okay, so here mechanical translation system means the system which is moving in a linear motion. That type of system is known as mechanical translation system. That means the system is move in a linear direction. And coming to the mechanical rotation system is moving in a rotating path, then the system is known as a mechanical rotational system. Now we are going to know about the mechanical translational system. Okay, now we are going to know about the mechanical translational system. Okay, see here, mechanical translational system. Okay, so here we are now going to discuss about the list of components used in the mechanical translational system. Okay, first one, X is the displacement of the system. Displacement of the system, and V is equals to velocity that is dx by dt. Okay, and A is the acceleration that is d square x by dt square, that is equals to A. So A is the acceleration of the system. And now we are going to know about some of the forces. So Fm is equals to opposing force offered by the mass, and Fb is equals to dash pot opposing force, and Fk is equals to opposing force. Okay, so these are the forces opposed by the spring. F is the applied force. Okay, here these are the terms we are using the mechanical translation system. Okay, note down this one. Now we are going to know about the force and how we are going to solve the differential equations for the mechanical translational system. Okay, actually just rub it. So here in the mechanical translational system there are three basic elements. First one is mass, it is denoted by M, and second one is dash pot, it is denoted by B, and third one is the spring, it is denoted by K. Okay, so by using this, F mass is the opposing force offered by the mass is Fm, and the force applied on, when a force is applied on the mass of the body, it gives some opposing force. That opposing force is known as Fm. So, and here Fb is the opposing force. Same, all the things are, when a force is applied on the body, some force is opposing on the same body. So we can take that opposing force as Fm, Fb and Fk. So now we are going to discuss about the individual basic elements of the mechanical translational system. Okay, so before going to know that, we are going to find the transfer function of the mechanical translation system by using Newton's second law of motion. Okay, by using Newton's second law of motion. So here we have two Newton's second law of motion. When a force is applied on the body, first one is when a force is applied on the body is equal to sum of the opposing forces on the same body. Okay, sum of the opposing force on the same body. Okay, this is the one of the Newton's second law of motion. And another one is sum of the opposing forces on the body is equal to 0. So here are the two statements. We are going to use these two statements in the solving of the differential equations and also for finding the transfer functions. Okay, so these are the very important Newton's second law of motion. Okay, now we are going to discuss about the individual elements. Okay, see guys, first one is the mass and we are denoted it as m. So from we all know that F is directly proportional to acceleration. Okay, to remove the proportionality constant, we add one more constant here. F is equals to m. M is the mass constant. Okay, m acceleration is d square x by dt square. Okay, so we already know that from Newton's second law of motion, F is equals to Fm is equals to Fm is the opposing force. So sum of the applied force is equals to opposing force, that is equals to m into d square x by dt square. So see here, this is the expression for the force balancing equation for mass. So let the mass be like this. Okay, when it is fixed to a reference and x is the displacement here, F is the force applied on the body and m is the mass. So this is the mass. Okay, now we are going to know about the dashpot. Okay, so see here the shape of the dashpot, and we denoted it as B. So this is the symbol of the dashpot. So it's we fixed a reference here, and B is the symbol, and F is the force, and X is the displacement. Okay, so for this the applied force F is directly proportional to dx by dt, that is nothing but velocity. Okay, so to remove the proportionality constant, F is equals to, we add a constant B dx by dt. So B is the friction for the dashpot. So from Newton's second law of motion, F is equals to Fb. So sum of the force is applied on a body is equals to sum of the force opposing on the same body. So B into dx by dt. This is the condition when the dashpot is fixed at one end. So next we are going to see the next condition, that the dashpot is have a displacement on both ends. So this one is the x1 is the displacement and x2 is the another displacement. So now we are going to see the what is happens when the both ends are moving under moving conditions. So now this is similar to that, F is directly proportional to d x1 minus x2 by dt. To remove the proportionality constant, F is equals to, so F is directly proportional to d by dt of x1 minus x2. F, to remove the proportionality constant, we are adding a constant b, and F is equals to Fb is equals to b into d by dt of x1 minus x2. So this is the expression for force balancing equation when both the ends are under moving condition. Okay, next we are going to see about the stiffness spring. See here the stiffness, the spring is represented as K, and the structure of the spring is like this. When it is fixed to one end, when a force is F is applied here, so the displacement is X. So now write the expression for, we already know that expression for force is directly proportional to X displacement. So to remove the proportionality constant, F is equals to K into X. So from Newton's second law of motion, everyone know that F is equals to Fk is equals to K into X. This is the expression what we got when it is fixed to a reference. Now we see that when it is two ends are in moving condition, x1 and x2 are the displacements, K is the spring constant. So F is directly proportional to x1 minus x2, and when to remove the proportionality constant we add a spring constant here k into x1 minus x2. Okay, by Newton's second law of motion, F is equals to Fk is equals to k into x1 minus x2. Okay, so this is the force balance equation for the spring when both ends are in a displacement condition. So friends, these are the differential force idealized element, force balancing equation for the isolated element, idealized element. So we, in the next class, we are going to know about the by using all these differential equations we are going to solve a problem. Okay, thanks for watching.